Today we will be solving system of equations by graphing. Okay, so in order to do this, we are going to graph the equations that they give us. Now, a system of equations, all that means is more than one. Okay, this terminology, system, just means more than one. And that means we're going to graph each of our equations, and we're solving by finding out which ordered pair do they both have in common. Okay, which ordered pair do they share? So if I'm graphing this first one, I have y equals -8. So I'm going to go to y is -8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and that means y is always -8. So I'm going to get myself a straight line here at y is -8. Okay, and then x equals -4. I'm going to go to -4 on my x, 2, 3, and 4. I'm going to draw a vertical line here. And the point that they both share is right here at -4, -8. Okay, and that means that that point lies on both lines. So this point makes both of the equations true. Okay, so let's take a look at one just a little bit different here. We have 3x plus 3, so I have 3 is my y-intercept, so I'm going to plot my point here. And then my slope is 3 over 1. So I rise 3 from my y-intercept. I go 1, 2, 3 over 1. And then I can draw my line. Then I'm going to plot my second point at -1. And I have the same exact slope. So I'm going to go rise 3, run 1, rise 3, run 1, and I'm going to plot that point. Okay, and when we plot both of those, you can see that these lines run parallel to each other. If they're parallel, are they ever going to cross? No, because they're parallel. Okay, they keep the same slope the entire way, which means they are never going to cross one another. Okay, so that means there is no solution. Okay, if they do not share a pair, there is no solution. Okay, let's try another one. So right here I have 4 is my y-intercept. Okay, it's really important too when you're graphing these lines that you make them pretty accurate, or else you might miss these things. You can see here though that the slope is exactly the same. So that is going to tell you that they're um, either the exact same line or that they are uh, that they're not going to cross. Okay. All right, now this one here gives you y minus 3 equals, so we need to get y by itself. So I'm going to add 3 to both sides to turn that into slope-intercept form. So plus 3, and I get y equals 2/3 x plus 4. And look, these are the exact same equations now. Okay, so when I graph +4 as my y-intercept and my slope as 2 over 3, and it's positive, I would do that for both of them, which means I'm going to get the same exact line both times. Okay? And when that is the case, that means every single ordered pair fits both of these solutions. So this is called infinite solutions. And that means I can pick, let's see here, I can pick 0 for my x, which means my y is going to be 4 for both equations. Okay, so I have y equals 4 2/3 times 0 plus 4. Okay, well, 2/3 times 0 is 0, and that gives me 4 equals 4. And that is going to be true for both. So this is infinite solutions. Okay, they're always equal. All right, and you can try this again for if you plug 1 into both equations and so on. All right, let's take a look at another one, see what we've got here. Now this one, you can see the slope is different for each and your y-intercept is different. So that is going to mean that these lines do cross. Okay, so let's go ahead. This one is proportional, which means your y-intercept is 0. Okay, because this is an imaginary plus 0 at the end there. My slope is 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Okay, and then I have y equals negative 2x plus 6. So 6 is my y-intercept. And then it's a negative down to over 1, down to over 1. And you can see our points both cross at this ordered pair right here, which is positive 1, positive 4. 1, 4. Okay, and now if I substitute this ordered pair into both equations, so I have y is 4 equals 4 times 1. Look, 4 equals 4 times 1 is 4, so that makes that one true. And if I substitute this into my second equation, negative 2 times x, which is 1, plus 6, I get negative 2 times 1 is negative 2 plus 6 is positive 4 equals 4. So that also makes this one true. So this ordered pair, 1 as your x, y as your 4, makes both equations true. So that is the solution. 1, 4 would be your solution. Okay, so again, your solution is the point that both lines cross each other. If the lines do not cross one another, there is no solution because there's no shared ordered pair. Okay, no matter what ordered pair, what numbers you put in, you're never going to get one that works for both. Okay, and that is because they have the same y-intercept, or sorry, the same slope, but different y-intercepts. Okay, again, no solutions. You have the same slope and different y-intercepts. For infinite solutions, that means every ordered pair that falls on that line will work for both of those. And that is when they have the same slope and the same y-intercept. Okay, the same slope and the same y-intercept. Okay, if they have different slopes, then you are going to have one solution. Okay, they can share the same y-intercept. Your shared ordered pair would just be the y-intercept if that were the case. Okay, and there are several more problems here that you can try on your own there, as well as these ones too, if you would like.